Okay, let's go to the next question. This is about the equilibriums of rigid body. Kan, eh? This is equilibrium of rigid body. Okay, this in Malay one is keseimbangan badan tegak. This is equilibriums in of the rigid body. That means this diagram will be in equilibrium conditions, no movement. That means the force, okay, the equilibrium of the rigid body, they we will see this one means the equilibrium of rigid body means sum of f x equal to 0, sum of f y equal to 0, sum of moment equal to 0. That means the force is in balance. Okay, 0 force is balance. Okay, that means no movement. Let's say if x force is high, have a value, then have a movement. Okay, uh, even though we can't see the movement, but actually at the body itself have a force. Okay, okay. This is the diagram we want to solve. Actually, at the joint diagram, we have a few type of a joint. This is one type of joint. Eh? Okay, let's say if you see this shape of a joint, let's say here, this we call joint pin. If you see this one, or something like this, this is we call roller. And if you see something inside the beam, okay, that's been built up inside the beam, inside the wall. This is wall. That's in the beam built up inside the wall. You call this one this built up in the in the wall. Then actually at this point, and this point have a force. Okay, if we want to draw the GBB, gambar rajah bandar bebas, or FBD, free body diagram. For the pin free body diagram, we will have two force. Okay, that means let's say this one is A, this one A. This is common use, use in the joint. Okay, let's say this is a pin. The force will be AX and AY. The directions is either positive or negative. We assume first. This is the body, okay, the frame. Force is like this. This is for pin, and for the roller, this is roller. The roller, the force will be direct to the roller. This means this is the force. Only AX. This means perpendicular to the surface of the roller. AX. Then for the beam mount to the wall, it will be 1 cos A x A y and 1 moment M A. Okay, this is the common free body diagram at the pin. Okay, this is for common use and knowledge. Okay, the question is this is the question. Draw the free body diagram of the beam which support the 80 kilogram load and is supported by the pin at A. Pin at A and a cable with wrap around the pulley of D. Okay. The questions want us to draw this diagram, free body diagram. Okay. Free body diagram. Okay, that means we need to draw back the beam, but without the pin. That means only the body of the pin and free body diagram. Force and force directions and dimensions we should write down or we should put in on our drawing. Okay, this is the beam. This is A, this is B, this is E, and at the end of this is C. Okay, at point A, point B, point E, and point C. Due to this A point is pin, got two directions, AX and AY. Same as previously I mentioned, the directions of the arrow we assume, okay, because at the end of our calculation, we will get whether either AX or AY positive or negative. Is positive, that means our our assumptions, the direction of AX is correct. If our result is minus, that means our assumption of direction AX is wrong. Okay, then B cable only one. Then other one is E is like this. Then this one is 4 3 5. Then C forces below 80 kilo 80 times 9.81, and this is a 2 mm, 2 meter, 2 meter, 2 meter. Okay, this is free body diagram we need to draw. This we call free body diagram. Okay, we already answer the question number 1. This is the question. Then the next question is determine the tension in the code and the horizontal and vertical component of reactions at support A. Okay. The next what we need to do is we need this one. We will down in this one T. This one also T. Okay. For your information, force at the pulley, this is pulley, force at the pulley, this force and this force same if the pulley is called frictionless. Let's say this one 50, this one also 50 Newton, same. Okay, if the pulley is frictionless. Okay, this one is for free body diagram. Later we'll continue our next session. We will continue to determine the tension in the code and the horizontal and vertical component of the reactions in the support A. Until now, or we draw the free body diagram first. Later on, we will continue with calculation. Okay, that's all.